Hello everyone and welcome back. In this video I'm going to talk about the breadth first traversal of a graph. In my other video you can watch the depth first traversal of a graph. Also you can watch the videos that I posted about traversal of a tree, both depth first and the breadth first traversal. So here there's an example of a graph G. We see there are 5 nodes and there are some edges which connects the nodes together. And here is the almost a pseudocode, or very close to the actual code of the breadth first search or breadth first traversal of a graph. So here, similar to what we did for like the breadth first traversal of a tree, we're going to create a queue. Because we're going to go from one, starting from one node, visit every neighbor of that, and then go to the next node and visit every neighbor of that. So in trees, we were visiting one level of the tree first, and then we're going to visit the next one. So that's not the exact case here, because graph is hard to actually show it in similar to the graph, and just a few graphs that can be or just special kind of graphs can be represented exactly similar to the trees. So because of that, we're gonna just to see that again, what the level means. Here means the neighbors of each node. So we're starting with enqueuing. I need to fix this one, is not the root actually. So we're gonna start with just one of the node, and although it can be correct if we just choose any node to be the root node or the first one, I'm gonna just, maybe it's a better term to just write first node. So we're gonna enqueue one of the nodes that we choose. It can be one specific node, or maybe randomly we can choose that one, or maybe we can call that node to be the root, or that vertex to be the root. So we're enqueuing the very first node. Let's say that in the graph G we're going to start visiting or traversing all the nodes by the node A. So let's call the first node to be the node A. So starting from the A, we're enqueuing that into a queue, and I'm going to just show you with this example that we have here. So the node A is enqueued in this graph, in this queue. Then what's going to happen, we're going to check if that while the queue is not empty for sure, which is not for now because we just enqueued the very first node, which is A. And if that node is not visited already, we're going to visit that node. So here I'm going to just put a check mark here saying that we have visited the node A. After that, we're going to enqueue every neighbor of the current node, we call it as we, or in this case which is A, into the queue. So what's going to happen, the node B and K will be enqueued, B and the node K. So, and here the node A is also dequeued. So as you see here, we first enqueued node A, and here we just dequeued node A. And then after visiting node A, we're removing that or dequeuing that, and then we're enqueued the neighbors, immediate neighbors of A, which are B and K. So, and none of them are visited yet. So going to the while loop again, because the queue is not empty, we're going to dequeue the very first thing from the queue, which is B. So B will be dequeued, and also that means that we're going to visit the node B. So I'm going to check the node B. Now for every adjacent of the node B, which is not visited, which are D and K, I'm going to enqueue them into the queue. So I'm going to dequeue. I'm going to enqueue the node D and the node Q, the node K into this queue that we have here. Then we're going to the while loop again, and here we're going to dequeue the next node, which is node K. So we're going to visit the node K, and as you see already, that's the order of like the visit. So visit the node A first, and then visit the node B second, and then the node K is the third one, which are the immediate neighbors of the node A. So now, because we visit the node B as a second, we expect to see every neighbor of the B to be the next one after we're done with the next immediate neighbors of the node A. And that's the case, as is here, the node D here is in the front of the queue. So we're going to dequeue the node like the D, so it's going to be dequeued, and then we're going to visit node D, so it's going to be the fourth node that we're going to visit, and then we're going to enqueue the neighbors of the node B. If you see the nodes, the neighbors of the node D are B, K, and C. However, we have already visited the node B and K, so the only neighbors that we can enqueue is the node C. So we're going to enqueue the node C. The next node, which is in front of the queue, is the node K, which has 3 neighbors, A, B, and D. However, we have visited all these nodes before, so nothing to be added. And also we have already visited the node K, so no checking again. And now we're going to just dequeue again the node K. And the very next one in the queue is the node C, which has only one neighbor, which is D, which is already visited, so we're not going to enqueue any other node. So we're going to check the node C is going to be the last node to be visited, and we're going to remove that from the queue. And as you see, there is nothing more in the queue, and that means that we're done. And that's how the breadth first traversal of a graph works. So we started from the the node A, then we visited the node B and D. Then from the node B started to visit the node D, and after D we visited the node C, and how it works. So again, you can just watch my other videos about the traversal of trees, both breadth first and also depth first. Also, you can watch my other video about the depth first traversal of a graph.